Hello my dear students, I am Mrunalini Hirpathak from Fergusson College and I have been teaching you C++, which is part of your Vocational Computer Science Paper 1. Last time we took a revision of our 11th standard C++ with functions, keywords, control structures, etc. Now I would like to start with our 12th standard C++, which is the object-oriented concept of C++, which includes classes, objects, etc. Yes, the topics that I would like to cover today are classes, object, memory allocation to an object of a class, the functions inside and outside the class, constructors and destructors, static members, array of objects, and friend function. Looking at the basic principles of or concepts of object-oriented programming, there are these 8 concepts: objects, classes, inheritance, polymorphism, data abstraction and encapsulation, dynamic binding, message passing, and exceptional handling. Out of this, the first 6 topics are part of your study material in your 12th standard. So we will be looking at them one by one. Now, advantages of C++ are very easy to implement and maintain. It can be expanded. Real-life systems like editors, compilers, and database communication systems can be made using C++. But there are limitations to the procedure-oriented programming in C++. When I say procedure-oriented means, you take whatever we have done in 11th standard. We start with the first sentence, continue, and end at the closing bracket. Object-oriented concept is slightly different. In the procedure-oriented, the whole focus is on functions and not on data. So if we want to share some data between 2 functions, we have to keep it global. More than 2 functions, we have to keep it global. In such cases, we say data flows freely in the system. So that means there is no data security in case of procedure-oriented programming language. In case of object-oriented programming language, emphasis is always on data and not on procedure. The programs are divided into number of objects. The data structure is such that it characterizes the objects. Each class contains data members and member functions. These functions operate on that data. Data can be kept hidden from the external functions. Objects communicate with each other through these functions. New data and new functions can be added easily without disturbing the original program or the original setup. It follows a bottom-up approach. An important question that they can ask you is the difference between the procedure-oriented programming and the object-oriented programming. In procedure-oriented programming, emphasis is on procedure, whereas in object-oriented programming, it is on data. Here, in procedure, it is the problem. Problem means the task that is given to us. It is viewed as a sequence of events. Example, you read some data, you calculate, and you print. In object-oriented programming, it is divided into number of entities called as objects. Large problems are divided into functions. Here, they are divided into class. In procedure-oriented programming, data flows freely in the program, whereas in object-oriented, we have the data is very much secured. In procedure-oriented programming, it is the top-down approach, whereas object-oriented programming has a bottom-up approach. The structure of an object-oriented program in C++ will always have this structure. It will have all the hash include files on the top, as they always are. Then we'll have all the declarations, then the member function definition, and void main. Remember, the compiler always begins its execution at main. That is why we call it as the bottom-up approach. Classes are the most important feature in C++. It is, remember, the member functions. So we can have as many number of data members. We can have as many number of functions inside a class. A class declaration looks something like this. Class and the class name. So that is the beginning of a class. Class name again is an identifier, that is a name that you would give to a class. Private and public are 2 new things that we are learning here. They are called as visibility label. We'll talk about them in the next slide. Then we have the member variables and the member functions. And we can have other set of member variables and member function. Always remember, the closing bracket of a class will always be followed by a semicolon. The visibility labels. Private members can be accessed only by the member functions of a class. So the data that you want to keep hidden from the outside, you can keep it as private. If you do not give any visibility label, default, those members are always private. Public members can be accessed from outside the class. So from outside the class, here we can say something that we want to access from main. Protected variables are used in inheritance. We'll talk about them in details when we talk about inheritance. Object. As I said, objects are the real life version of a class. Now, when we say classes are user-defined data types, objects are variables of that particular class. We can also say objects are instance of a class. Now, when a class is actually created, no memory is allocated to it. But when the memory is allocated to it only when the object of that class is created. Now, I've taken an example here. Class student. So we have created a class. I've just written nothing inside it. Just close the class with the semicolon. Void main. In this, I have said student S. Now, S is a object of the class student. Now here, I've given an example. Int I, where I is a variable of the basic data type int. Student S is a variable of the user-defined data type student. So user-defined data type, we are using pretty much as if it is a built-in data type. Simple, I've taken a small program with a class. As I said, hash include iostream and conio.h at the top always as they are. Class, I've taken an example. I've taken 3 data members here. As I said, data members are all the integers and the floats and the characters that you have. So I have 3 integers, a, b, and sum. In the public section, I have a function which is add, and here what I've done is a is 10, b is 20, and sum is equal to a plus b, which will be 30, and then I print that sum. In void main, what I've done is example obj. Obj is the object of this example class, and now I say obj dot add, very important concept, wherein using the object we are calling the member function of a class. So now this class, because it is a public member function, we can access it outside the class. So add can be called in void main. CLR and get CR, CLR SCR and get CH as they were. Now comes the memory allocation in a class. Now we remember we have 2 things grossly divided. A class can be grossly divided into 2 parts. Data members and the member functions. What happens to data members when the objects are created? So every object will get a copy of that data member. So if I have 10 variables, all the objects, and I have created 10 objects, all the 10 objects will get the set of all the data members that are there. What happens to member functions? So member functions are shared. I've taken a small example here, trying to explain you. Class A, of course, hash includes on the top as they always are. Class A is a class, and I have 2 variables here, var1 and var2. Function 1 and function 2 are 2 functions. I've just taken them. I've given no body to the function, no definition, just using it just to explain you. In void main, I have created 4 objects of class A. So I've written A, obj1, obj2, obj3 and obj4. Pictorially, I would like to show you this is I have created these 4 objects, object 1, 2, 3 and 4. Each object contains a set of the data members, which is var1 and var2. Again, var1 and var2 for object 2, var1 and var2 for object 3, var1 and var2 for object 4. So every object gets 1 copy of the data members, whereas functions, only 1 set is created and all the objects are going to share the function. This is a very important concept to understand how classes and objects work with functions and data members. As I said, we have functions in the class, member functions. Now, how do we write these functions? There are two methods of writing these functions. One is we write it in the class and another one is we write outside the class. I will explain this to you along with the example. So in the class, I have taken a class student where I have an integer data member, which is roll number. I have written two functions here, get roll, which will obviously read the roll number. So enter your roll number, C in roll number. Then the next function is put roll, which will obviously display the roll number. Void main has student S. So S dot get roll, S dot put roll. Again, I have used the dot operator to access the member function. Now what is important here is the class closes at this point, and both the functions I have written inside the class. So this is how you write a functions inside a class. Generally, the functions that are small can be written inside the class. How do we write outside the class? Now, same program, I have written the function outside the class. Here again, I have one data member, which is roll number. Then I have two member functions, which is get roll and put roll. Now I have written, the class is closed at this point. So I have written this function outside the class. So get roll is the function, void is the return type, and as we know that we are not passing any arguments here. What is important is this scope resolution operator. This scope resolution operator tells me that the scope of this particular function get roll is from this particular class, which is student. So we have get roll function, which is in the scope of class student. The function body remains the same, enter your roll number, C in roll number. Similarly, when I say I'm writing the put roll function outside the class, we have to specify with a scope resolution operator, which says that the put roll function belongs to the class. So if I say the syntax, it is going to be the return type, the class name, the scope resolution operator, the function name, and then the arguments. Again, void main, the function main body doesn't change. It is as it is, student S, and using the dot operator, I'm calling get roll and put roll functions. The next important point in C++ object-oriented programming part is the constructor. What are constructors? So constructors are special member functions. Now why special? Is because they have the same name as that of the class name. This is important. If you have a huge program in front of you and you want to find out which is the constructor, then the constructor will be the one function that will have same name as that of the class name itself. So it has the same name as that of the class name. Next is why do you use constructor and why the name constructor? It is because it is used to construct the object, or it is used to initialize the object of a class. This is the second important point. And the third one is they are invoked or they are called automatically when the object of that class is created. So I have here class name, and class name with a function is a constructor. I've taken a small example here. This is a class integer where I have two integers m and n. Then I have public. In public, I have this constructor integer, which is a function. Now remember, these two brackets always imply a function. So this is an integer and it has same name as that of the class name. So it is a constructor. And I have initialized the m and n to a particular value here. So another example wherein I have two constructors. Now in the first one, both the constructors have the same name because obviously constructors are going to have the name of the class itself, but the argument list here and here are different. If I do not pass any argument, we call it as default constructor. If I am passing any parameter in a constructor, we call it as parameterized constructors. So a small example of a constructor with default and parameterized constructors. I've taken a class ratio. Ratio has, obviously it has a numerator and a denominator. So I have used a variable num and dem. Public, I have ratio. Now since ratio and this function has same name as that of the class name. It is a constructor. And since I'm not passing any parameter to it, it is a default constructor. So I've said numerator is 0 and denominator is 1. Then I have another constructor in which I'm passing the parameters. So I have int x and int y. X I give to numerator, y I give to denominator. So this becomes the parameterized constructor. Void display will simply display ratio as num/den. Now void main. Void main, CLR, SCR as it is. I've taken ratio x. Since I'm not passing any parameter, x will call the default constructor because it has no parameters. So x object will use the default constructor to initialize the value of num and den, and z will use 10 and 20 to display or to initialize the value of num and den. So when I say x.display, I should get 0 by 1, and when I say z.display, I should get 10 divided by 20. What are characteristics of a constructor? Characteristics of a constructor basically should be the same name as that of the class name. That is important. Then they are always in the public section of the class, obviously because we want to create an object. It should be used outside the class. Then they are always automatically called when the objects are created. Important thing, they do not have any return value, not even void. Now, the other points are for our future references where we are going to study inheritance, but we'll just look at them. They cannot be inherited. Then they can have default arguments. You remember we have done default arguments in the last lecture. They cannot be virtual, and they can make an implicit call to the operators new and delete, which are the memory allocation operators. Like constructors, unlike constructors, we have destructors. Constructor allocates some memory to the object and initialize the object. Destructor destroys, or doesn't destroy actually, it releases the memory which was occupied by the constructor or the object of used by that constructor. So destructor releases the memory back to the memory heap. It is always, again, it will have the same name as that of the function class name, but it will always be preceded with the tilde operator. Destructors do not take any argument. They also do not have any return type. So in this example, class name, this is a constructor, and obviously this is a destructor. Taken a small program which is there for your practicals also. Class ratio. In ratio, this is a constructor. What I've done is I've said that object is born. Print is a function where I say the object is still alive, and then I have a destructor here which says the object is dead. In void main, I simply create the object ratio r. Once I create this ratio r, your constructor is going to be called and it will say the object is born. When I say print, it will say the object is still alive. Now when will be the destructor called? It will be called when the closing bracket in the block in which it was created comes to an end. So at this point, the destructor will be called and it will print the object is dead. Array of an object. Now, array of objects. We have studied array of variables, where integer variables, 10 integer. Similarly, we can have array of variables which are of the type class. Okay, these are called as array of objects. They behave similar to any other arrays that are there in C++, and to access these arrays, the method remains the same. So we can use the index of that particular element to access that particular function also. For example, I've taken a class employee, so EMP. I've simply just closed this class. I've not written anything here. Just to explain you, I've taken main and I have created EMP object of 10 elements. So this will create 10 objects of the EMP class. All of them will have the name object, but the index will be different. Just like how we have in arrays, the first element will start with a 0, and in this particular case, the last element will be 10 minus 1, 9, because we've started with a 0. Remember, in C++, arrays will always start with 0. No other initialize element will start with the 0 index. No other initialization is permitted. Next one, the static data members. Static members are usually used to maintain some values that are common to entire class. Now, suppose I've taken here an example in class integer, static int count. Count will be a variable where I want to count the number of times I've created the object. So it should be common to all the objects that are there. So static members are the ones that will only one copy will be created for them that will be shared. So what are the characteristics of a static member variable? They are always initialized to 0 when they are initially created. Obviously, there is only one copy. Always remember when I say in a class data members, all the objects get one set of the data members, but not of the static data members. So only one copy will be created and that will be shared by all the objects, no matter how many objects are being created. Next important point, it is visible only for that class, but its life is throughout the program. Just like how we have static data members, we have static member functions. These have the following properties. They can ask you a question about what are the characteristics of static data members. So static functions have access to only other static members. So they can have access to static functions or static data variables, which are declared in the same class. Again, that is also important, that it should be from the same class. Static member functions can be called using the class name itself. You don't need to have an object name and the dot operator. We can use the class name instead of the object. Next, friend functions. Now, let me explain you why do I need friend functions. As I said, the variables can be private or public. So when I say a variable is private, it is available only inside a particular class or that particular class. When I say it is public, then it is available outside the class also. That means anybody can use it. There could be some variables which I would like to keep private, not public. I don't want everyone to access it, but I want one or two other classes to access those variables. In such cases, I use a friend function. Here, friend is a keyword. So situation where I need some data to be shared between two classes. I don't want to make it global. I don't want to make it public. So in such cases, I can use a friend function. So non-members cannot share the data of private data of a class. So C++ allows a function to be made friendly with both the classes. In such cases, because it is a member function of both the classes, it can access the private members of both the classes. So I've given an example here. Class ABC, friend is a keyword, void is the return type, and XYZ is the function name. So friend is the keyword, friend will always be defined as a normal C++ function. It does not require a scope resolution operator. Mind you, if we write any function outside the class, we should always use a scope resolution operator, not with friend function. Friend functions should be written as a normal C++ function, which we have been using in our 11th standard. So there are some characteristics that are associated with a friend function. These are not in the scope of any class to which it belongs. So it doesn't belong to a single class because it is shared by more than one class. Next important thing is it cannot be called using objects. Like we said obj1.getData. So we used object and getData function. But we cannot have friend function that can be used in this way. So it can be called as a normal friend function. It can be declared in the private and the public section. Generally has objects and argument and we do not need a dot operator. I have taken a small program in which I'm going to again find the factorial of a given number. What is different here is it is an object-oriented program. So in the exam, if they tell you write an object-oriented program, that means it is expected that you write it with the class. The logic of finding a factorial of a given number, that remains the same. I have data member here, which is n. Of course, let me tell you, hash includes iostream.h and conio.h will be on the top as they always are. Then I have this function, member function void find. Then I say, write the function outside. So return type is void. Find is the function name. Scope resolution operator tells me that the scope of this find function is in the fact class. So while I is less than or equal to n, I say answer is equal to answer into I. So I will start with 1. Answer is also 1. I will move from 1 to 2 to 3 to 4. Let us say we are trying to find the factorial of 4. So we'll have 1 into 2 into 3 into 4 as the factorial. Void main, we say enter the number. We say find fact. Fact f1 is the object and we call the function using f1 dot find. So using object-oriented programming, same factorial we can find using a slightly different way. As I said, the logic remains the same. Yes, my dear students, we have now started with the object-oriented concepts of C++ with classes and objects, writing functions inside and outside the class. In the next chapters, in the next sessions, we will start with inheritances and polymorphism, which are further concepts related to object-oriented programming. Thank you, students. See you then.